Hello, welcome back to my channel. In today's video, we will discuss logistic regression. Let's get started. Logistic regression is a supervised machine learning algorithm widely used for binary classification tasks such as identifying whether an email is spam or not and diagnosis diseases by assessing the presence or absence of specific conditions based on patient test results. Logistic regression predicts the output of a categorical dependent variable. Therefore, the outcome must be categorical or discrete value. It can be either yes or no, 0 or 1, yeah, true or false, etc. But instead of giving the exact value as 0 and 1, it gives the probabilistic value which lies between 0 and 1. In logistic regression, instead of fitting a regression line, we can fit an S-shaped logistic function which predict two maximum values, 0 or 1. Types of logistic regression. On the basis of the categories, logistic regression can be classified into three types. First, binomial. In binomial logistic regression, there can be only two possible types of the dependent variables such as 0 or 1, pass or fail, etc. Multinomial. In multinomial logistic regression, there can be three or more possible unordered type of dependent variable, such as cat, dogs, sheep, and third, ordinal. In ordin in ordinal logistic regression, there can be three or more possible ordered types of dependent variables, such as low, medium, or high. Now, how to perform logistic regression using Python? First of all, load the required packages and import the clothing cells. Here we said consider a data set as clothing cells training and clothing cells test data set as a cell sales train and sales test respectively. Here the clothing cells training and clothing cell is a data set. Import pandas as PD, import numpy as np, import stats models.api as sm from spicy import stats. SCIPY. Cell strain equals to PD dot read CSB. Here we read cell strain dataset, training dataset, and we store it in cells train. Cells test equals to PD dot read CSB. Clothing cells test. Here we read clothing cells test dataset and stored in cells test variable. For simplicity, we separate the variables into predictors, variables x and response variable y. Add a constant to the x data frame in order to include a constant term in our regression model. X equals to PD dot data frame cells train days comma var. X equals to sm dot add constant x. Y equals to PD dot data frame cells train cc. To perform logistic regression, use the allogit and fit method. Save the model output and run the summary to command on the saved model output to view the model result. LORE LOGREG01 equals to sm dot logit y comma x dot fit LOGREG01 dot summary to validate the model, perform the same step on the test dataset. X test equals to PD dot data frame cell test days wave. X test equals to sm dot add constant x test Y test equals to PD dot data frame cells test CC. LOGREG01 test equals to SM dot logit Y test comma X test dot fit. LOGREG01 test dot summary 2. This is the whole code of logistic regression. Code is successfully executed. Confusion matrix is created 1020. Classification report, precision recall F1 score support. Now, now Poisson regression. Poisson regression is used for modeling count data and rates. It assumes that the target variable follows a Poisson distribution and predicts the expected count for a given set of predictors. How to perform Poisson regression using Python. Naturally, in order to validate our modeling results, you would first split the data into training and test datasets. Load the required packages, import pandas as PD, import numpy, import statsmodels.api, import statsmodels.tools.tools. Read the churned dataset into the Python as churn. Churn equals to pd dot read CSV, path of the data. Our predictor variable is churn, which is categorical. Similar to previous modeling task, we need to change the categorical values of churn into dummy variables. For this exercise, we will use one dummy variable, which equals 1 if a customer has churned. Churn IND equals to pd dot get dummies, churn, churn, comma drop first true. The getDummies command creates two indicator variables, one for each categorical value in churn. The drop first equals to true input will drop the first dummy variable, which corresponds to churn. False churn equals to false in our case, and retain the remaining dummy variables, which corresponds to churn equals to true. The remaining command saves the new dummy variables as a data frame, add a constant term. So our regression model will have a constant and renames the column so the output will be easier to read. X equals to pd dot data frame churn ind. X equals to sm dot add constant. X dot columns equals to constant comma churn equals to true. We also prepare the response variable y equals to pd dot data frame churn cust serve calls customer call I think. Finally, we run Poisson regression using the glm command poisreg01 equals to sm dot glm y comma x comma family equals to sm dot families dot Poisson dot fit. Notice the three input values of the GLM command. The first two y and x specify the response variable and predictor variables respectively. The third family sm.families.poisson specifies that the Poisson regression should be used. The fit command will fit the model to our data. We save the result in POISREG01. Use the summary command to view the result of the model. POISREG01 dot summary. This is the full out. This is the whole code of Poisson regression, and this is the output of Poisson regression. Thank you for watching. Stay tuned for future videos. Don't forget to like, subscribe, and share.